Hello. Again, I wanted to record some extra examples for the probability units for each section. And these examples, again, are from your homework. So if you're having any problems with your homework, then you can look over here and hopefully get some extra assistance. So our first example from the first section is find the probability of obtaining 6 heads when flipping 6 coins. So we want the probability. My pen's not working. Okay, I think it's working now. So find the probability of obtaining 6 heads when flipping 6 coins. So there's only one chance of getting this out of a total number of possibilities, and the total number of possibilities would be found by 2 to the 6th. And the reason it's 2 to the 6th is because there's 2 possibilities, heads or tails, and we're flipping 6 times. So it's 1 over 64 is the probability of obtaining 6 heads. Or you could have that as a decimal, and usually with probability problems, your homework will ask for to the millionth place, and so that's 6 decimal places. So 0.01565 would be the decimal. Make sure you round for that last unit there. Okay? Example 2 says, which of the following statements is an example of classical probability? So classical probability is also sometimes called theoretical probability. Let me take the bell off my kitty so he doesn't keep ringing. And it is based on theory, so not based on an experiment or an observation, but based on theory. So let's look. A says, Heather wants to know the percentage of students who are from her home state. So each day of her first week of classes, she asked 30 students where they are from. So this one is an example of an experiment that she's conducting. It was essentially, she's asking people if they're from her home state. So this would be empirical probability, not classical. B says Jimmy is figuring out the percentage that the first fish he catches today is a bass. The pond where he is fishing just stocked with 100 fish, 30 of which are bass. So he could theoretically figure out the probability of catching a bass by putting 30 over 100. So this is an example of classical probability. So B would be our solution, but let's go ahead and look at the other two to see why they wouldn't be classical. To find the percentage of times that 5 of the same number will be rolled when rolling 5 dice, Tom rolls 5 dice 50 times a day, each day for 50 days, and records the results. So again, this is an experiment where he's rolling dice. This is empirical probability. And D says in order to find the percentage of red cards in a large pile of playing cards, Camilla draws 50 cards and tallies up the number of black and red cards she sees. So she has counted the number of cards. Also, I don't know how that got there. Also, empirical probability. And example 3 says a recent survey showed that 91 full-time employees out of a sample of 500 did not use all their vacation days last year. However, 105 of those studied expressed a desire for more vacation time. Based on this sample, if a full-time employee is chosen at random, what is the probability that he or she is content with vacation allowance? Now, I'm not particularly happy with this problem because it's not specific in the question that it asks with what it's been given. But it is, you are able to figure it out because we can see that 105 expressed a desire for more vacation time. So they must not be content. 105 of the employees are not content with their vacation time. So out of 500, we would subtract the number that are not content, and so we know that 395 employees are content with their vacation time. Doesn't have anything to do with the 91 that didn't use their vacation time. They are assumed to be content with what they got. So the probability that a content employee is selected is 395 out of 500. We'd want to reduce that. If we leave it in fraction form, that'd be 79 of 100, or as a decimal, 0.79. Okay, so there's our 3 examples to help you more with section 1.